Welcome back to Tech Society, the podcast delivering candid conversations with smart people, tech and business leaders, academics, and more about their big ideas and how they're changing our world. Now your hosts, Alex Dunmo and John Newen.
Today we delve into the world of Paul Nicholls, Director of Research Partnerships at Curtin University. Paul is responsible for the university's demand-driven research strategy, which aims to help industry and government get better access to university R&D capability. With an extensive and very distinguished background in research and education across Western Australia, Paul is one of the most powerful leaders in connecting the university with industry and government. Of massive interest to Tech Society is his critical role in shaping ICT and emerging technology across WA. Listen on to see how Paul is involved with the Square Kilometre Array and the Pawsey Supercomputing Centre.
For the people who don't know, like me actually, what does university research actually look like?
So there's probably two traditional, the two models for, I guess, research in university. There is the traditional knowledge development where researchers will, come up with new ideas and pursue them through experimentation or just thinking about the new ideas and putting forward new propositions for their colleagues. And a lot of the time that involves applying for grants. So there are grants that Australian government support through the Australian Research Council, the National Health and Medical Research Council, to develop that new knowledge and those new insights. And the success rate of those grant applications is in the order of between 15 and 25%. So when you're lucky enough to win one of those grants, you then go away and do your piece of experimentation or you write your publication, and then you move on to the next piece of work. So that's sort of the traditional model, and that's common across the world.
So actually, to be honest, incredibly ignorant. I had no idea that was a thing. So the private companies actually come to Curtin University and pitch their problem almost. Yeah,
and look, there's lots of different mechanisms for that. Ultimately, the university is there and it does that as part of delivering a service. And so a company might make contact with a researcher and that they've become aware of, that might have skills in a particular area, let's say, geophysics and optimizing and understanding of the Earth's core. They might come to the university and say, look, we've seen this insight, we've seen this data. Can you help us analyse this data to understand what it means, which might then be utilised to go and drill for a particular resource or for mapping out a future exploration. So that's just one example. And for us, we're also heavily involved in data science, data and computational sciences. Curtin and the University of Western Australia partner with the WA state government in a very large project called the Square Kilometre Array, which is building one of the world's biggest radio telescopes out in the middle of the Murchison Radio Observatory. And that particular area is really interesting because not only are we looking at data that's flowing at ridiculous volumes and speed off these instruments, these sensors in the middle of the desert, what's needing to happen is we need to build up really strong capabilities around data analysis. So the same skill sets can be used to look for insights and understanding inside those data sets.
What's the status of the array?
So it's always a good question to ask. I wouldn't want to say exactly what the time frame is, but we expect that there's already operational telescopes. So a radio telescope is unlike a light telescope. A radio telescope looks at a different part of the electromagnetic spectrum, the radio part. So they can see different things than what you might see in a light telescope. So these sensors, they're very passive and pretty cheap. So you place them out in a radio quiet zone where there's no technology. So WA out in the desert is a pretty good place for that.
What are some of the big wins of the university industry collaborations in the past few years?
I think if you have a look at the WA government and some of the priority areas that we have in Western Australia, radio astronomy is one, computational science is another, the Minerals Research Institute of WA, ICRA, which is the joint venture around radio astronomy, the Marine Sciences Institute, the WA Marine Sciences Institute, and the Biosecurity Institute. So they're some of the priority areas for Western Australia. And in terms of then industry partnerships, you will probably be aware that the federal government has established what's called industry growth centres in the last few years, and they're in areas such as mining and engineering, in energy resources, cybersecurity. We're looking to try and ensure that universities are more responsive to industry, that the intellectual property that's developed ends up going somewhere and doing something. So I guess we are looking for partnerships where industry see challenges. And an example is the mining industry, for instance, has gone through a rapid digitisation in the last probably 4 or 5 years, as not only we've gone through building new infrastructure, particularly in Western Australia, but we've also been able to access sensors a lot more cheaply. So companies naturally have gone and done that, thinking that, okay, once I've got those sensors, I'm going to have a lot more data and I can then improve the way I operate. Well, the challenge with that is actually taking that data and doing something with it. When universities or research institutions are quite good at helping to develop those insights. So one of the projects, getting to my point, is the establishment of the thing as a very long-winded thing, which is short for we're basically going to train a pile of PhDs to work inside companies to actually understand their data. With those PhDs and postdocs are probably going to become the employees of those companies. So we're developing knowledge for them on how their data, how their maintenance is occurring, and then moving that from, monitoring data to becoming more predictive and, trying to estimate when failures are going to occur and intervening before they do. So that initiative is a partnership between Curtin University of Western Australia, CSIRO, BHP, Roy Hill and Alcoa, and the Nichols Research Institute of WA, all partnering together to solve, a problem that individual institutions might take a long time to solve.
Absolutely.
Yeah. So
what are some of the challenges for such a diverse group of companies and departments?
Well, of course, the companies don't want to hand over their data. That our PhDs are sitting inside one company and not moving between companies is one of the challenges. Ensuring that the supervision of those PhDs and postdoctoral students is consistent across those institutions, and ensuring that when we develop insights, that those insights have somewhere to go. So we want company to be heavily involved in developing up the problem for us before we throw a student or an academic into the data set, which is a critical piece. And I think it's one of the misnomers or myths that some companies have had, which is, here's a pile of data, I'm going to give it to you, you're going to give me an insight and I'm going to take that away and make a lot of money out of it.
I believe they call that garbage in, garbage out, don't they?
Well, yeah, for sure. One example of that is a researcher at Curtin. So he looks at an industrial process and optimizes it using mathematics. We, as a university, had a company. A couple of companies have come to us and said they've got a problem with the way that they do shutdown of their plant. And so as they do it, it's very expensive, takes a lot of time. Often the right parts aren't at the right place at the right time to replace. So it's just an inefficient process. So he was asked to go away and do some optimization of that process, which he did, and was paid to do the research. What you end up with is some optimization code or an algorithm. You don't actually end up with a solution. So the next piece of that is that algorithm is then taken as a piece of intellectual property and given to a third party to develop that into a shutdown maintenance piece of software. So I guess understanding where the university's research finishes and begins is a critical part in that as well.
That's actually quite interesting, because solving the problem is only half the problem. Then you have the actual usability of something, the implementation.
Yeah. And we call that, research translation, or the pathway to impact, and making sure that there is a pathway. And I think I mentioned earlier the intent that, the research, the industry partner is involved in developing the problem. So the context of a problem, particularly in the data science and computational fields, is critical. What does this mean in an operational environment? One of the other really important industry partnerships that we've developed is a thing called Innovation Central Perth, which is a partnership between Cisco Technologies, Woodside Energy, Curtin University and CSIRO Data 61. And when you have a look at the original partners in that were Curtin, Cisco and Woodside, and you look at them and Woodside was a customer that had challenges. We don't talk about problems, we talk about challenges, opportunities for improvement. And Cisco was a technology company that could enable very fast, reliable, secure networks, which is critical in terms of the deployment of sensors or Internet of Things technologies. And then you had Curtin as a university that can provide two things: undergraduates that are trained in those things, but also research to actually look at a particular problem. So there's this great example of a project we did with Woodside where up on Kilometre gas plant, which has been around for a long time, the fin fans, which cool the gas down to a liquid, which is an important part of the process because you want to be able to move it. The liquid's a lot more compressed, like 1/600th of the size of the gas and a lot more stable. So part of that is the fin fans, which are like a fridge, right? They cool the gas down to a liquid. There was about, I think, 860 of these fin fans, and they're all about the size of 2 kitchen tables put together. And each one of those is along a gangway. And the challenge with that was that these things would break down, and the only way they could work out if they were going to break down was someone would walk up and down those gangplanks regularly and do two things. They would look for physical damage, and then they would also listen for different sounds and feel different vibrations as well. Now, we said, oh, that's great. We think now that you get cheap acoustic and vibration sensors and we can stick them in the plant and we can wire that up to a new network and you'll be able to monitor and predict failure. I said, you're not doing that experiment on our operational plant. So the value of the Innovation Central Perth was that you could actually then we went and built a fin fan on the campus, got it operating, got some cheap acoustic and vibration sensors, had a look at what normal behaviour looked like or normal data signatures, and then we damaged it. So we'd put a notch in the belt, or we'd put some sand in the races, or we'd damage the bearings. And then you could all of a sudden see what a failure would look like. So once you'd done that experiment and shown that to the operators, and all of a sudden the confidence level around what's possible was opened up. So there's a real cultural shift, not only for industry in how you might trial those, but of course for the researchers. But I guess the important piece of all of that is that you need to have the researchers and the industry and the technology partners all in the same conversation when they're trying to tackle some of these problems.
And just capturing enough data to solve one of these problems can take quite a long time. Even with experimenting with one of those units, I'm sure you still need close to 1,000 units over a long enough timeline to actually catch.
Right, that's where supercomputers come in handy. You can actually model those things using statistical regressions and those sorts of analytics. So yes and no, I guess would be my answer with that.
What does that look like? Which I know is like a really open-ended question, but most people have no idea what simulating models entails. So can you kind of give us a quick...
So hands up, I'm not an academic and I'm definitely not a mathematician. My background was actually neurosciences and education, but I think what you can actually do is basically simulation modelling. So you can build a model and then trial changing different factors in those models. Every time you change a factor, you've got to rerun the model. When you've got a supercomputer, you can change multiple factors and rerun the models multiple times to get the optimization that you're looking for. And there's lots of different techniques that they use to do that. But it's a lot simpler and cheaper to do experiments on a supercomputer than it is to do them in real time. So you can't do experiments across Western Australia on, let's say, climate change, for instance. You can't go out and put sensors and model that and wait 100 years to see if the climate's changed, but you can actually do that model on a supercomputer. Yep.
What does it look like? Because you mentioned that there's a lot of industry and university collaboration. When the undergrads have a project to work on, like the fin fans, for instance, do they get seconded to the Woodside engineering offices to learn as well from the engineers over there?
Yeah, so there's lots of different models, and this is, I think, one of the things for universities. We need to be flexible in how we work with industries, but a traditional internship we do as part of courses. Students will have capstone projects, usually in their third or fourth year, where a company will help formulate a problem for the student to work on. But we also have summer internships, and they run in a number of places. So we run them with Innovation Central. So a researcher, an industry partner will have an IoT type problem, and we will allocate an academic to work with the industry to supervise or co-supervise an undergraduate student. So the first step to that for an undergraduate student will be to understand the problem. So they spend a lot of time at the front end with the industry, then formulate a project plan on how they're going to solve that problem. And then they'll go through and spend 6 or 7 weeks going right through the full process of understanding, trialling, proof of concept to insight. and then there'll be a readout back to industry after about 10 weeks. So that's a great thing for a number of reasons. One, obviously, the student gets an opportunity to work on a real world problem, right? So straight away, you've got students who understand what it's like to work in a company. The industry itself, this is a cheap way for them to engage not only the student but also an academic. So they've got the sort of try before you buy for an undergraduate. They're also getting a little bit of a look at the problem that they're facing and how a university might go away and solve that problem. And then thirdly, for the university, the benefit for us is giving our students real world examples to work on, and therefore employment opportunities, but also our academics building a relationship with the industry as well. So quite often those short-term projects with the undergraduate, where we're paying the graduate $500 a week for 12 weeks, $6,000. Quite often that leads to longer-term relationships with industry and larger projects that deliver impact back into those companies.
Yeah, it was. It's interesting because I studied engineering at university, and I did do an undergraduate secondment basically to one of the big alumina refineries, and same thing where I learnt a lot. And I imagine like a lot of these undergrad to academic supervisor arrangements is basically how they do a lot of their theses and final year projects. And basically a lot of this is mostly for the engineering department, I imagine.
Data science.
Yeah, look, I wouldn't characterise it as that. So in the IoT world, sensors everywhere. So manufacturing, engineering, mining, oil and gas, agriculture, a lot of sensor, built environments, a lot of sensors as well. So
what is this is a bit of an antagonistic question, but what is the point of the connection between industry and academic? Is it because universities have the ability to be right on the cutting edge, the bleeding edge? Is it because they have more access to the supercomputing facilities? Is it because they have students who want to learn and see things in a different viewpoint? So what's the advantage here?
So I think about it in a couple of ways. One, that industry is very singularly focused on what they're trying to achieve. They work in a lot shorter cycles, so they're working at a cadence that is very, very fast. Universities don't have to work at that cadence, right? So universities are going to be around for a long time. They usually have been around for a long time. They have broad capability. They have multidisciplinary capability that companies do not have. Sorry, that's not fair, but don't always have.
Or are already being utilised heavily.
Sure. Yeah. There's the BAU, and when you try and get a company like a mining or an oil and gas company to say, let's go and do co-development or innovation, it's really, really a challenge to provide them the thinking space and time to focus on that sort of forward-looking activity when they're still trying to keep things operating on a day-to-day basis. So there is that ability for academics to, I guess, work at a longer time frame, look further out around what's happening in a particular sector. There is the opportunity for them to work on things that industry just don't have time to work on. We also want graduates to be trained in these areas. So, the pathway for graduates into employment is critical. And if you're not training those graduates on leading edge technologies and information, then they're going to require a whole lot of retraining once they get inside a company.
So what's the connection? How does integration work? Does a university come in as a contractor into the organisation?
So in terms of research, there's lots of different models. I'm going to give you a very open answer to your open question. My job is to actually help build those models for industry. So I mentioned one, which was Innovation Central, very short proof of concept, use the university as a living laboratory. There is a traditional contractor model, which is we'll sit down with you and understand your problem as an industry. We'll break it right down into all the different pieces, and then we'll put together a contract with you if you think we can help deliver value. And that contract needs to be very clear on expectations around milestones, time, cost, what will be delivered, what are the outputs, what are the inputs from both organisations. The inputs can include data, technology specialists inside the companies, their time, and it might be something that we can do in 6 months, or it might be something we can do in 4 years with a PhD student that we might work with together. So Then we have a whole lot of joint venture models where, we have industry university partnerships. We have, Bankwest Curtin Economic Centre, for instance, where a bunch of economists that work with Bankwest to develop insights on the West Australian economy. We have partnerships with government agencies, again, to look at areas in their own that can deliver impact into the government. I'm just trying to think of some of the other industry partnerships. We also have industry roundtables where we share knowledge. So industry comes in and says, these are the things that are keeping us awake at night. The universities will talk about, here are some of the skill sets we have. And coming out of those things, there might be internships, PhD funded PhD students, there might be bilateral contracts, there might be three-way agreements. And then the final piece is that there are a lot of funding schemes that are demand-driven in the sense that we need industry as partners. So one example is a Cooperative Research Centre, which is a three-way partnership between the federal government, industries and universities on a particular area, and they'll work together. So every organisation puts $1 in, and so you end up with a 3-to-1 return on your investment. So you can actually reduce your risk as an industry, because for every $1 you put in, the industry, the university and the government will put in $1 as well. And there's lots of different schemes like that, some smaller, some larger. So there is value in leveraging and utilising university partnerships for industry.
What are the challenges what are the challenges you face in this role?
Yeah, interpretation. So industry speak a different language to universities, to academics. So I'd spent a lot of time coaching academics about industry, but also a lot of time teaching industry about what drives academics, because they are different creatures and there are things that will work well together and there are things that will never work well together. And as a researcher, you will never be pigeonholed in one or the other. Sometimes you might do traditional research, but every now and then you might move into an applied area. So that flexibility, and it's not right for every researcher, right? Some researchers you would never stick in front of the industry because they're not, the industry will just not understand. They will not understand what industry is trying to achieve, and industry will not understand what the academics trying to achieve.
Before we continue this podcast, here's a message from our sponsor.
We believe that you can create art and beauty with technology. We think big. We move quietly. We are Ninja Software.
Seeing as you're kind of AI and robotics adjacent, what's your prediction for the future as far as robots taking our jobs?
Good question. We're getting better and better and better at interpreting data at scale. And we talked about the radio astronomers and the square kilometre array, that as we get increasing volumes of data, the ability to interpret that with humans becomes lower and lower and lower. So we need machines. That's the first point. The machines will only answer the questions that the humans put to it, I guess is my view. And we talked about context. Huge volumes of data mean nothing unless you actually train the machine to interpret it the right way. In terms of West Australia and the West Australian context, digitisation, automation, remote operations is clearly the transition that we're going through in the mining, oil and gas sector. We're starting to get more heavily involved in space and defence. And the movement of remote operations type technologies between those more traditional sectors and future sectors is increasing, and there's more mechanisms for that to occur. The humans are just going to need to have different skill sets, and I think that's where universities see they have an important role. There's two parts to that. One is developing new graduates, and I think the second part is retraining those people already in the workforce. So, one figure I've seen, 70% of the workforce that we're going to need by 2030 is actually already in the workforce. So we're going to need to retrain them because the acceleration in these technologies is phenomenal.
If you were about to become a university student, 17, you've just graduated, what area would you go in? What area, as a Western Australian, do you think there'll be demand for, especially with research and development, doing cool stuff? What's the most exciting field to get into? 2020, 2021.
So do your passion first. And I've got 4 children. 2 of them are at university and one is currently year 12. So the first one, passionate about chemistry, did chemistry, and also passionate about education. So he's doing teaching in chemistry. The second one, passionate about music, but also really strong mathematically. So doing music and economics.
Oh, wow. It's quite a combination.
Yeah, it's very, very interesting.
The units don't overlap as much as you'd like.
The jazz economist.
Yeah. Well, I still, but enjoys it.
That's great.
And he's building a skill set. I always believe that you can learn to learn inside a university, and once you've done that, you can apply yourself to lots of different things. The third one, the third child is really, really strong in mathematics, but not quite sure what to do with it. And I'm saying, do computer science, do mathematics, do data science, do one of those fundamental subjects which really stretches your thinking. I think that child will probably be the most employable because that skill set can be applied in multiple different places. So I think if the world was my oyster, I'd be doing data science, right? And you can end up anywhere. In Western Australia, you might end up in a mining company doing that. On the East Coast, you might end up in finance. In the US, you might end up, controlling autonomous vehicles. There's just the world is your oyster with that skill set. And interestingly, we talk a lot about data science now, but if you talk to some of the academics that have been around for longer, they see it as just maths and statistics, but at a larger scale. So I think we shouldn't convince ourselves that we don't have data scientists already in our community. They're the maths stats people that have gone through and in the last 20, 30 years.
So jumping back to the present, so there's a lot of cool science education stuff you were covering in SciTech as well.
Mm-hmm.
Do you feel that we're doing enough today to teach children STEM and encouraging them to approach science in a less wishy-washy fashion, but a more engineering-focused mindset? There's a lot of initiatives to teach them programming. There's engineering courses in high school now. Is that enough to prepare them for this very technologically focused society that we're heading into?
Never enough. Never enough, John. I think we still face the challenge of crowded curriculum. The importance of literacy and numeracy can't be questioned. How you apply, how you teach science and find time for science and engineering in the curriculum is really difficult for a teacher. We spend a lot of time as universities trying to build that into our curriculum in the way that we train our teachers as well. The role of what I will call informal education centres and SciTechs, museums, observatories and the like, Perth Zoo, Aqua, these groups that provide not only an entertainment experience but also an educational experience are really critical in broadening the opportunities for kids beyond the formal classroom. And I think universities see themselves having a really important role in that as well. So you'll see the universities spending a lot of time delivering outreach into schools, and they do it for 2 reasons. They do it, one, because they want to upskill, but they also want to attract those students.
Yeah, more students,
as well. Yeah. So we are also a business. We're a not-for-profit business, but part of our business model is actually securing students, and we always want the best and brightest, and we want to be the best and brightest. But Curtin itself is also very strong in terms of equity and making sure that all students, all kids in high schools have an opportunity to go to university if they can. And we're a firm believer that if you get a higher education experience, you are more likely to be a valuable contributor to society, more likely, less likely to be a burden on society, and also you're going to be more educated. And we've seen that in with COVID-19 in the last 6 months or however long, that the education of the community has been critical. And you're finding in some of those communities that are less educated and internationally that are less developed, the spread of this disease is really strong. We're very lucky to sit in a country and a state where education, higher education is valued and people understand the implications of hand sanitisation. Sorry, not touching your face and all those sorts of things. So big believer in providing equitable access to higher education and the role of informal education providers supporting formal education.
All right. I think we won't take up too much of your time. I think we'll just...
Yeah. So I guess to close this off, let's say we were a business, which we are, but we're a hypothetical business.
When we have other hats on, we are.
Sure. That's right.
Right now, we're podcast interviewers.
Yeah. And I don't know. We're a software company, hypothetical software company, and we've hit a snag in one of our problems. You know, the universities have a pool of people that can help us.
Sure. Maybe we have 5 petabytes of data, and we know what we want from
it. 5 gigabytes, and so and we want some business intelligence, business knowledge. Too much to go through, and Excel's not really helping. Clustered databases also not helping.
No.
Who do we talk to? What do we do?
So I think the first thing is, if you don't know, you don't know what you don't know. And there's an important initiative that was established 2 years ago called the WA Data Science Innovation Hub, or Woodside. So that's a joint venture between the state government and Curtin to actually raise the profile of data science and help SMEs, so small to medium enterprises, find access to not only educational resources for companies, but also graduates and problem solving for exactly the sorts of things you're talking about. So I'd encourage you to go and visit, first of all, let me just check my Woodside, WADSIH.
That's actually really interesting. I've never heard of that before.
That's a shame. Yep,
WADSIH.
Yep, .au.
So any listeners out there, if you're sitting on petabytes of data,
you can subscribe. Subscribe to that. You'll find a lot more. There's blogs and information resources for all the universities and private providers. And I guess that would be the first place I would go. If you decided that the capability that you needed might sit at Curtin, which is a fair chance it will. We're very strong on the data science capability. Then my own group, Research Partnerships, we facilitate these sorts of things on behalf of the rest of the university. So someone will knock on the virtual door or on the physical door and say, I've got a problem, I'm looking for a capability. And I will then work with that company to better articulate and understand the challenge, and then find the right resources to work through a better understanding of that challenge, and then turn that into a solution for you in some way, whether that's through an internship, a PhD scholarship, a short piece of contracted research, or a long-term piece of work, or a partnership, right through to an alliance agreement like we have with Cisco or Optus, for example.
Fantastic.
Excellent.
All right. Yeah, I think we'll close it off there. That was a really good point to end it.
There you go. All right. Well, look, thanks very much. Really appreciate the opportunity.
Yeah, thanks for your time, Paul.
Thanks so much for being on the show. Thanks, Paul.
See you then. Bye.
See you then. And there you have it, another episode of Tech Society.
On this day in tech history, Alexander Graham Bell and Thomas Watson demonstrate their first two-way phone call over outdoor wires. Bell and Watson made their call between the cities of Boston and Cambridge in 1876. It's pretty amazing how far we've come, and the fact that you're listening to this streaming over the internet. Crazy to think.
If you liked what you heard, visit techsociety.fm to check out more episodes. Any comments? Just tweet us at TechSociety. This episode was sponsored by Ninja Software at njs.dev.
That's it from John and I. Over and out.